I'm going to jump right in here. Notice how these expressions here that you see, A, B, C, and D, they look a little bit different than what we're used to. I'm actually going to ask you to factor them. And you might be thinking, well, how am I going to factor this? Well, look at this is what I want you to notice about each one of these. And I'm going to change to a highlighter real quick here. Notice how in A, you look closely, you see something in common between this first part, I'll say the first half of the expression and the second half of the expression. So if I break it up, first half and second half, you see how there's something the same here and here? What do you notice that's exactly the same? You should be thinking 2x plus 1, right? So 2x plus 1, 2x plus 1. You see it 2x plus 1, 2x plus 1. Go to part B. Do you notice anything that's the same here and the same here? Well, of course, x minus 2, x minus 2. Okay? Anything that's the same in the first half and the second half of the expression here? X minus 7, x minus 7. And how about here? X plus 4, x plus 4. So we have something in common between the first half of the expression and the second half of the expression, the first half and the second half. Now, these are called, in each of these cases, they are called common binomials. We're used to factoring common monomials. So what I'm talking about with common monomials is if you had like 4x squared plus 2x. What's common here and here? Well, I have a 2 and a 2 because 4 is 2 times 2. So I can divide a 2 here and a 2 here. So what's common? 2, 2. What else is common? X, x. But so 2x, this would be 2x times 2x plus 1. That's how you would factor this, right? So 2x is the common monomial. These all have a common binomial. And the common binomial in this case is 2x plus 1. So what we're going to do is we're going to pull out that common binomial. Like here, we pull out a common monomial. We say, all right, 2x, I'm going to pull it out. And I'm going to write whatever's left over by dividing, right? So if I divide this by this, what do I get? 2x. If I divide this by this, what do I get? 1. Okay? This is what's left over. This was the common thing. Here, I have a common 2x plus 1. That's my common factor. It's not a monomial, it's a binomial. So I'm going to pull that 2x plus 1 out of each one, but I'm only going to write it one time. I'm only going to write it one time because I only wrote the 2x one time, right? When I did this, when I factored this, I only wrote that common thing one time. So I'm writing the common thing one time. It's the exact same process except it's a common binomial. What's left over? Well, what's left over here? If I take 2x plus 1 and divide by 2x plus 1, what am I left with? I'm left with just this guy. I'm left with just x. What's left over here? 2x plus 1 divided by 2x plus 1, what am I left with? I'm left with 7. So I'm left with x plus 7. I'm left with x plus 7. See how it's the exact same thing as what you did over here? You were left with 2x and you were left with 1. You're left with x, you're left with 7. That's what's left over. So I take 2x plus 1, my common factor, and x plus 7 is my leftover. You might want to write a note for that. So this right here, this 2x plus 1 was the common, and the x plus 7 was the leftover. Okay? And that's kind of how we're going to do these. 5x, x minus 2 minus 4 times x minus 2. We already said the common binomial was x minus 2. X minus 2. So what's the leftover? If I take out the x minus 2, what's left? 5x. If I take out the x minus 2 here, what's left? Minus 4. So x minus 2 times 5x minus 4 would be the factors. What was common here? We said x minus 7 was common. Take out an x minus 7. What's left over? Well, there's going to be a lot left over. So x plus 4 is left. And also what's left over here? X plus 1. So all the leftover stuff, you could put it together. And now we're going to combine because we have like terms. So again, x minus 7 is the common binomial, and we can combine the leftover stuff. X plus x is 2x, and 4 and 1 is 5. So you're left with x minus 7, 2x plus 5. So right here, these would be your factors. Okay? Here we had an x plus 4 that's common. So I'm going to take that out. And then we're going to do our leftover, 2x plus 8 minus x minus 2. Now I'm going to put that in parentheses because it's a minus. You have to minus both of those two things. So we're going to do a little bit of work here. So x plus 4 is our common. You're always going to have that by itself as one of the factors. And then the other factor is going to be whatever's common. 2x minus x, that's just x. 2x minus 1x is x. 8 minus a negative 2. 8 minus negative 2. See that negative goes to that? 8 minus negative 2 is 10. 8 minus negative 2 is 10. All right? So x plus 4, x plus 10 would be the factors. Now, we're going to start from scratch. We're going to be given an entire polynomial right here. See this? A whole polynomial. And we're going to use our what's called factoring by grouping to look for a common binomial. So we're going to set it up to look like what we just did, and then you'll see the common binomial, and then it's easy from there. Okay? So take a look at this right here. There's no common factor for all 4 terms. By the way, this only works when you have an even number of terms. It's got to be 4 terms, 6 terms, 8 terms. It's got to be an even number of terms, so we can have even groups. All right, so we have 4 terms here. Here we have 4. Here we have 6, and here we have 6. We're going to factor by grouping. So we're going to group. Let's just group the first 2 and group the last 2. Okay? Just group with the ones that are right next to it. All right, so here we have we're going to look for a common factor between the x to the 5th and 4x to the 3rd. Forget about this. Okay, forget about that for now. Just focus here. What's the common factor? Well, x to the 3rd is the common factor. So we're going to take out an x to the 3rd, and then we're going to say what's left. All right, well, what's left? X to the 5th divided by x to the 3rd is x squared. And then 4x to the 3rd divided by x to the 3rd is just 4. So this times this gives me this, right? I didn't care about that right now. Now I'm going to move over here, and now I'm going to do the same thing. Let me change colors. Do the same thing with this pair right here. What's the common factor over here? 2. What's left over? X squared plus 4. See that? So I focused on just the first pair and did a common monomial. Then I focused on the second pair, did a common binomial. Now it looks like all the ones we just did up here. It looks like these. Okay? There is a common binomial. What's my common binomial? X plus 4, x plus 4. If you don't get a common binomial, this method isn't going to work, and you probably did something wrong. Either you did something wrong or it doesn't work, or you can't factor it. Okay? So see how there's an x squared plus 4? I know that x squared plus 4 is going to be my one factor, and then my other factor is going to be what's left over, x to the 3rd, and then plus 2. And that's it. X squared plus 4, x to the 3rd plus 2. Those are my factors. All right, let's do it again. So I have 18x to the 3rd. Oops, sorry about that. I have 18x to the 3rd plus 9x squared minus 2x minus 1. So focus on just this group right here, or you can also split down the middle. Sometimes they say they call it split the middle instead of factor by grouping. You could split it down the middle and worry about just this pair and this pair separately. So if you want to look at it like that, that also works. What's the common factor? 9x squared. All right. So what's left over? 2x and then plus 1. And then you could just check to make sure that works. Here, there's no common factor, but we want to make it look like 2x plus 1. So what we're going to do is take out a negative 1 and then say 2x plus 1. Okay, negative 1, 2x plus 1. All right, so see the common binomial, guys? I'll highlight it one last time. I'm not going to do this every single time. See the common binomial? That comes out 2x plus 1. What's left over? 9x squared minus 1. Now it turns out we can actually factor 9x squared minus 1 more, but we're going to do that in tomorrow's lesson. So pretend you can't do anymore. If you're thinking, wait a minute, 9x squared minus 1, that can be factored more. You're right. You're right. We're just not going to do it today. Okay, you'll see that in lesson number 9. All right, now, these are a little longer, but it's the same idea. Okay, pair them up. All right, what's a common factor here? X squared. What's left over? X plus 3. Okay, what's a common factor here? 5x. What's left over? X plus 3. What's a common factor here? So this is this is that, and then this is going to go here. Common factor of 2. What's left over? X plus 3. Look at that. X plus 3, X plus 3, X plus 3. We have a common binomial in each part of the big polynomial. So X plus 3 is my common factor. And then I can, what's left over? I have an X squared left over here. I have a 5X left over here. And I have a 2 left over here. So that's my leftover. So my factors are X plus 3, X squared plus 5X plus 2. And then we would try and factor that, but that can't be factored anymore. So you're done. And then one more. What's common here? We have, we'll change colors. We'll do, we'll do 3 here. Okay, be 3 times x minus 2. That's this group right there. And then we'll do this group. 5x squared times x minus 2. And then we'll do this group, which is x times x minus 2. All right, and then we'll put it all together. Common factor, x minus 2. Hope you're starting to get the hang of it. And then 3, 5x squared, and x is going to be left over. I'm going to write it in the correct order. You can go in that order. It's fine. It doesn't matter. I just like having my biggest exponent first. So I'm going to write it as 5x squared plus x plus 3, all left over. And there are my factors, okay? So that's the first part of this lesson. We have one more part of the lesson. It's another type, and I mentioned this earlier. We'd have a new way of factoring these types of trinomials. It's called the AC method. We did this factoring, like 2x squared plus 11x plus 15. You guys know how to factor that. You know how to do, don't write this. You know how to get two binomials and go, all right, 2x, x, and then how do I get 15? 5 times 3. I'm going to put my 5 here, my 3 here. I'm going to put my 5 here and my 3 here because I know it's 5x and 6x. Don't write this. 5x and 6x, right? And that gives me 11x, so I know it's got to be 2x plus 5 and x plus 3. Right? So we know it's going to be 2x plus 5 and x plus 3. Some of you like that method and are good with it. And some of you were like, I'm not too sure. Maybe there's another way to do it. Here's that other way of doing it. All right, we're going to do that in this lesson here. It's called the AC method. Here's what you're doing. It takes a little bit of practice, but once you use it, you might like it better. You're going to multiply the A value times the C value. So that this is the A value, whatever's in front of x squared, and the C value is whatever's in front of, or whatever's by itself, the constant all by itself. So this is how it works. You go 2 times 15, and that's 30. Okay, so now you take 30. You take factors of 30. All right, so do a little factor tree. How do I get 30? 1 times 30, 2 times 15, 3 times 10, 4 doesn't go in. 5 times 6. Okay? Now, of that right there, from those choices, we're going to try and get 11. Now remember, the old method, you had to do guess and check. So you weren't sure, whatever. We're going to try to get 11. So how do we get 11? 5 and 6, right? So we're going to use, and I'm going to erase this just because I'm running out of room, but we're going to use 5 and 6. But instead of going right to the factors, you're going to set it up so that it's a factor by grouping problem. So we said 5, 6. We said 5 times 6 is what we're going to use, all right? You're going to rewrite, okay? You're going to rewrite this polynomial as a 4-term expression. So we're going to keep the 2x squared the same. Let me change colors. 2x squared is staying the same. 15 is going to stay the same. All right, plus 15. It's the 11x that we're going to break up. We're going to break up the 11x into 2 separate terms using the numbers we found right here, 5 and 6. So we're going to call it plus 5x and plus 6x. So notice we changed the original polynomial to a new polynomial. It went from 3 terms to 4 terms. Why would I want to make it more complicated? Because now you can use the grouping method we just learned above. So if you like that factor by grouping, you can do it now. What's a common factor here? X. What's left? 2x plus 1. I'm sorry, plus 5. 2x plus 5. What's a common, here's the grouping, right? Group, group. What's common here? 3. What's left over? 2x plus 5. See that? Look for a common binomial. What's my common binomial? 2x plus 5, 2x plus 5 times x plus 3. And isn't that, go back and rewind the video, isn't that what we said the factors were going to be when we started off, the old method we learned? So there it is. That's another way to do it. So that might be like, oh, you might think that's more complicated. I could just go and do it the other way. That's fine. You could pick and do it however you want. I just want to give those people who are having trouble with the other method another way. But let's do it again. A times c. So 5 times 2, right, is 10. So, okay, so A times C is 10 for this one right here. So what are the ways to get 10? I'm just going to do it off because I'm going to run out of room here, so I'm doing it on the side, right? 1 times 10 and 2 times 5. How do I get 3? Obviously 2 and 5. 5 minus 2 is 3. So we're going with 2 and 5. We're gonna make this 5x squared. We're going to go plus 5x. Then we're going to go minus 2x. And then keep the minus 2. So what did we do? We kept 5x squared. We kept minus 2. We broke up 3x to 5x and negative 2x. 5x and negative 2x, that does combine to 3x. Why 5 and 2? Because that's what gave us 3. 5 minus 2 gave us 3, factors of 10. All right? Now factor by grouping, what's a common factor? 5x. What's left over? X plus 1. What's a common factor? Negative 2. What's left over? X plus 1. X plus 1 is my common binomial. And 5x minus 2 is left over. It's magic. There are my factors that I could have done just right from the original polynomial, like the original trinomial, and make product of 2 binomials just like we've been doing all year. Okay, let's do one more. 7 times 4. 7 times 4 is 28. Okay, so factors of 28, that give me 16. How about 2 times 14? How's that? How's 2 times 14? Is that 28? Yes, it is. What's 2 and 14? 16. So we're going to go, change colors again. We're going to go 7x squared. We're going to go minus 2x minus 14x. You got to go negative, negative to make the negative 16. And then plus 4. Keep that the same. So what's the common factor here? We're going to group it, right? Group it. Common factor is x, leaving 7x minus 2. Common factor here is negative 2, leaving 7x minus 2. And of course I have a common binomial of 7x minus 2 and x minus 2 is what's left over. And my factors are 7x minus 2 times x minus 2. We will practice this and the regular factor by grouping in class tomorrow. See you then.